by the component of the uh, acceleration due to gravity along the line toward the center. So the acceleration which is acting on the body toward the center of the circular path is called centripetal acceleration. So centripetal acceleration is going to be square by r. In this case, that centripetal acceleration is provided by g cos theta. Therefore, g cos theta. This is equation number 1 you can write. Or we can write, sorry. Or v square is equal to r into g cos theta, you write. This one you take as equal equation number 1. That's also done. Now, what is the vertical distance traveled to the body? That is equal to r minus h, right? Okay. So at this point, what is the velocity of the body? The body is moving downwards. What is the velocity of the body at that point? To calculate the velocity of the body, downward velocity of the body at this point, that means along the tangent. What is the velocity of the body? To calculate what we can write. Now, v square is equal to u square plus 2gh. There is a formula here when a body is moving down with the acceleration as equal acceleration due to gravity. Then v square is u square plus 2gh. What is the vertical distance traveled by the body in this case? H is equal to r minus h. U square, u is equal to 0. Why? Because the body is starting from rest. Therefore, we can write 0 plus 2 into g into r minus h also we can write. So, v square is equal to 2g into r minus h. This is equation number 2. So, two equations you got. One equation you got, v square is equal to rg cos theta. Next equation got, v square is equal to 2g into r minus h. Why 2g into r minus h? Very clear. Because when the body starts from this point and reaches at this point, p, the vertical distance traveled to the body is equal to r minus h. In the downward direction, the depth or height traveled by the body is r minus h. So, in the second and the third law equation of linear equation of motion, third equation of motion, we have v square is equal to u square plus 2gh. Right? As the body starts from rest, u square is equal to 0. Plus 2g into h. What is the vertical height the body moved as it reaches the point P? That is equal to r minus h. Very clear? Right. So this also v square, this also v square. Both can be equated. Therefore, we can write rg cos theta is equal to, from 1 and 2 you write. From 1 and 2, we can write rg cos theta is equal to rg cos theta is equal to 2g into r minus h. We can write this. Now, cos theta, the value of cos theta can be calculated. Cos theta is equal to h by r. Cos theta is equal to h by r. That also can be calculated. H divided by r. Right? So this one, if you draw a line here, right? This line, this h divided by r. So from the diagram we can write here. From the diagram we can write cos theta is equal to h by r. This also h only. You can take h, this, and this is r. You can write. Okay. Am I correct? h by r is equal to cos theta. Therefore, we can write this as equal to rg cos theta. That means r into g into cos theta is equal to what? H by r. H by r. Okay. Right. So this is take as equal to r. If this taken like this, then this is equal to base by hypotenuse. Base by hypotenuse, h by r is equal to 2 into g into r minus h. This r and r cancel. This g and g cancel. Therefore, h is equal to 2 into r minus h. That is equal to 2r minus 2h. Therefore, 2r is equal to h plus 2h. that is equal to 3h. That is R is equal to 3 into h by R. 3 into h by R. What is h? H is the position of the body. At that point, the body starts detaching from the surface. At that time, what is the height of the body from the ground is what is called h. So h is equal, we have proved as equal to, h is equal to, h is, 3h, na? Therefore, h is equal, we are calculating. Therefore, h is equal to 2 into r divided by 3. I am very sorry. 2 into r divided by 3 we can write. So this is the height of the position of the body at which the body gets detached from the surface of the hemisphere. So this is one question. Another question I am writing on the board. That is a homework for you. One homework I am giving you this time. Right? That homework question also I am writing here on the board. A simple pendulum of length L. Question 6. A simple pendulum of length L has a mass M. Has a mass M. If the pendulum is raised, to 90 degree, and left, then find the tension and velocity at the mean position. Then find the tension and velocity at the mean position. At the mean position. Right. So a simple pendulum I am drawing here to make you understand, that's all. This is a simple pendulum. Okay. Now this pendulum is taken to this point. Pendulum is taken to this is raised to this point and left free. This is L only. This also L only. When it is left free, it comes down from a dropping point to this point. This is the mean position. When the pendulum is left oscillating, the mean position, the middle of the position when no force is acting is called the mean position. Suppose that it is not disturbed, the pendulum will be at this position and it will be always keeping on at the same position only. That is what is called mean position. When it is disturbed, then the bob will move to and fro with respect to this point. That point is called mean position. In this case, what is that? This bob is taken to 90 degree. 90 degree it is taken up and left. The body reaches to this bottom, what is called the mean position. At that position, what is the tension in the spring? Tension you have to calculate. And also at this point,